Welcome to HP Tuner's Forward Mod Motor Training Part 6. This video we're going to be taking a look at our PCM Logic Operation. So what that means is we need to understand on a fundamental level what forward engineers have programmed our PCM to do, how it's supposed to think, and how it calculates our fuel and our spark timing and everything that goes along with that, because it's essentially how it's controlling our engine. If we don't understand things fundamentally on a basic level, we can't go in and properly calibrate them and tune them. So let's jump in now and talk about how this is going to work. Now we have a fundamental underlying equation on this particular PCM of how everything's going to be calculated for fuel and spark timings, particularly our fuel, which is going to be our fuel mass is equal to our air mass divided by target air fuel. Now I'm talking about fuel mass and air mass. That might be something that you're not familiar with. Let's break this down a little bit further. Now when we're talking about the mass of a substance, this is going to be the volume and the density. So we can relate to this a little bit better. If we're taking a look at a cup of water, we know what the volume of that cup is going to be, and depending on the substance we place in the cup, that'll change the mass of the cup filled with that particular substance. So if we're talking about a cup full of water, we can determine what that mass is going to be. We know the volume of the cup. We know the density of water. Now, if we take that same cup and we fill it with gold, we know that that mass is going to completely change. Even though the cup is the same volume, the density of gold is much different than water. So we have two different substances, two different masses, and therefore we understand now the concept of mass. It's volume times density. Now, when we're dealing with our forward PCM, we're dealing with our underlying equation that's going on. We have fuel mass is equal to air mass divided by target air fuel. Now let's break this down so we understand what air mass and fuel mass represent. So when we're dealing with our airflow coming into the engine, we know on our particular forward PCM here, we're going to have a mass airflow fitted to the intake track of the engine. That's going to be registering the amount of airflow that's ingested into the engine. Now that mass airflow sensor will allow us to determine the volume portion of airflow that's coming into the engine. Now that's going to give us the volume. We need to know the density. There's going to be a barrel pressure sensor fitted to the engine, also an intake air temp sensor fitted to the engine. We can use the barrel pressure readings to determine our elevations, determine our density, because as we go up or down in elevation, that drives our density up or down. And also our air temperature is going to be a factor within our density, because if we have cold temperatures, we have more oxygen molecules packed into the same volume of air, compared to warm air temperatures where we have less oxygen molecules. So basing on where we have our elevation we're operating at and our air temperature, that can drive our density up or down. Now we have to combine the volume flow, measure from the mass airflow sensor, and we have to measure and then combine it with the density to give us the total amount of air mass. Once we know the air mass that's entering the engine, we can go in and specify what we want the engine to run at as far as our desired target air fuel. So again, fuel mass is equal to air mass divided by target air fuel. We would know the air mass if we would know and specify what we want the target air fuel to be at. So idle part throttle driving, that's typically going to be 1.0 lambda or stoichiometric, which is going to be the equivalent on a gas petrol air fuel scale of 14.7 to 1. So that's going to be idle cruising conditions. Again, we know what the air mass is going to be. We've specified what we want the desired target air fuel to be, or the desired lambda to be. We can figure out what the fuel mass is going to be. Now the fuel mass is going to be the volume and the density of the fuel that we're dealing with. Now when we're talking about fuel mass specifically and we're trying to figure out what kind of fuel we need to deliver into the engine, we have to factor that in terms of our fuel injector. The fuel injector is going to be what squirts the fuel into the engine in a controlled manner. Now, when we change injector sets, we have to represent the different volume flow of the injectors that we're using, so the PCM knows exactly how to command that injector open and close to deliver the fuel that we're requesting so that we deliver the fuel mass that we're calculating. It's very, very important that we characterize all this right. So this is all going to be handled by separate tables within our PCM. If we're looking in our mass airflow section within our calibration file, we're going to have what's known as our MAF calibration curve. This is going to be taking a look at the voltage output from our mass airflow sensor. That's going to be registering what the volume flow of air is going to be. And then knowing what the volumes or the voltage is going to be, we're going to be knowing what the volume flow is going to be. We know what the barrel pressure and air temperature are going to be. That can combine all of that in its calculations. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.